Hello future engineers, welcome to my YouTube channel. If you're still new to my channel and you like what I'm doing, please don't forget to share my videos to your friends and to your friends' friends. That's one way you can keep me going, inspired and refreshed. Now if you find my videos interesting and important to your studies, also please don't forget to subscribe. So this is a portion of distributed forces. So still on locating centroids of volumes, areas, arcs or lines, and the corresponding derivation of formulas or volumes, as well as for the locations of the centroids or center of gravity, which is very important in the succeeding topic on uh, beams subjected to loadings, line loads, concentrated loads, or surface loads. Level 26. Using the method of composite curves, locate the centroid of the plane curve shown. So let us tabulate the solution, and let's call this element 1, element 2, element 3. And this is the centroid of element 1, centroid of element 2, centroid of element 3. So for the tabulation, we have element, area, length rather, S in mm, then x sub c of individual element, y sub c in mm, then product of L and x sub c or sxc in mm squared, then s y sub c from Varignon's theorem. So we have elements 1, 2, and 3. For element 1, the length is 60 mm, this length here. Its barred x is here. So since this is the y and the x-axis, it is 30 mm leftward of the left to the left of the y-axis, so it's negative 30. The y sub c is above, so half of 60, so it is positive 30 mm. 60 times negative 30, negative 18, 60 times positive 30, 1800 mm square. Then for element 2, the length is pi r, pi times 30, so 30 pi. Its barred x, it lies on the y-axis, so it's 0. Its barred y is 60 plus this distance. This distance is 2r over pi. So 60 plus 2 times 30 divided by pi is, let's put the value here, 79.099. Then the product 30 pi times 0, so it's 0. 30 pi times 79.099, it's 7454.905 mm square. For element 3, the length is square root of 30 square plus 60 square by Pythagoras theorem. So 30 square root of 5 mm. Its x sub c is the x coordinate of the midpoint of this point, so half of 30, that's the midpoint, so 15. Or right x plus left x, right x 30 plus left x 0 over 2, so that's 15. Similarly, upper y 60, lower y 0, divide by 2, so 30 mm, that's y sub c. And 30 square root of 5 times 15 is 450 square root of 5. 30 square root of 5 times 30 is 900 square root of 5. So summing up the lengths, this is 221.33 mm square, summing up s x sub c. So take note that s x sub g equals summation of s x c. So we have to sum up this. And xg therefore is this sum divided by the sum of the lengths. So negative 793.77, and s summation of sy sub c divided by s is the value of yg. So that's it. So xg is equal to negative 793.77 over 221.33. So the x coordinate of the centroid is negative 3.586 mm. Then YG is 11267.37 over 221.33. So YG is equal to 50.91 mm. So that's it for this problem. Level 27. Using the method of composite curves, locate the centroid of the plane curve shown. So let's call this, for the solution, let's call this element 1, element 2, element 3. And let's tabulate the calculations. So we have element, the length in mm, the value of x sub c of individual element, y sub c of individual element, the product of length here s, and x sub c, product of length s here, and y sub c in mm square. So for element 1, the length is 87.5. This is the centroid. And barred x is, it lies on the y-axis, so 0. Barred y is half of 87.5, so 43.75. Then sx, so 0. 87.5 times 43.75, 3828.125. Then for element 2, the length is length of semicircular curve pi r, pi times 50, so 50 pi. That's the centroid. The value of barred x is 2r over pi, but negative. It lies to the left of the y-axis, so 2 times 50 divided by pi is negative 2 times 50 over pi is negative 31.831. Y sub c is, it lies here, so it is just 87.5 plus radius 50, so 137.5. Then 50 pi times negative 31.831, negative 5,000. 50 pi times 137.5, 6875 pi. For element 3, it's the length is half of this, pi r over 2, so 25 pi. That's the location of the centroid. X sub c is the positive of this value, 2 times 50 over pi, so 31.831. Y sub c is 87.5 plus 50, 137.5 plus 2r over pi, 2 times 50 over pi, so 137.5 plus 31.831, 169.331. Then 25 pi times 31.831, 2,500. 25 pi times 169.331, 13299.23. So the sum of the lengths, 323.12 mm. The sum of sx sub c, this column here, is negative 2,500. And the sum of sy sub c here is 38725.8. Therefore, xg is negative 25 over 323.12. So xg is negative 7.737. Then yg is 38725.8 divided by 323.12. So yg is 119.8 mm. So that's it for this problem. Level 28. Using the method of composite curves, locate the centroid of the plane curve shown. So for the solution, let's call this element 1, element 2, 3, 4, then element 5. So the length of element 1 is 125 plus 100, 225. So the centroid lies here, so its x sub c is 0, xc1 is 0. Then half of 225 is 112.5, since this is already 100, and the centroid lies below the x-axis, so it is negative 12.5. Y sub c1 is negative 12.5. Then for element 2, the length is S2 is 75. X sub C2 is half of 75, 37.5. Y sub C2 is 100. It's 100. Then S3 is 100 mm. The centroid is here. So XC3 is 75. YC3 is half of 100, so 50. Length of element 4 is 125, radius minus 75, so 50 mm. The centroid is here. So 75 plus half of 50, 25, so 100. XC4 is 100. Then it lies on the x-axis, so YC4 is 0. Then for element 5, the length is pi r over 2, 125 pi over 2, 62.5 pi. Then the value of x sub c is 2r over pi, 2 times 125 divided by pi. It's here. And that is XC579.58. The value of y sub c5 is also 2r over pi but negative, so negative 79.58. So the sum of the lengths has total 646.35. So adding all these lengths here, then summation of Sx sub c equals 225 times 0 plus 75 times 37.5 plus 100 times 75 plus 50 times 100 plus 62.5 pi times 79.58, and that is equal to 30,938 mm square. So xg can now be computed, summation of Sx sub c divided by S total. So 30,938 divided by 646.35. So x sub g is equal to 47.87. Summation of SYC. So 225 times negative 12.5 plus 75 times 100 plus 100 times 50 plus 50 times 0 plus 62.5 pi times negative 79.58, and that is equal to negative 5938 mm square. So YG is negative 5938 divided by 646.35. So YG is equal to negative 9.187 mm. Level 29, the horizontal x-axis is drawn through the centroid C of the area shown, and it divides the area into two component areas, Area 1 and Area 2. Determine the first moment of each component area with respect to the x-axis and explain the results obtained. So here is the given figure. We will call for the solution, let's call this B, BB, then by similar triangles. So we have similar triangles here, this big triangle and this small triangle here. So the dimension of this small triangle is B minus 24. So B minus 24 as to 84 equals 72 minus 24, which is this, as to 84 plus 60 is 144. So solving for B, B is 52 mm. So if B is 52 mm, that means this base of the triangle, right triangle, is 52 minus 24, so 28 mm as shown. And for this triangle here, 72 minus 52, so 20 mm. So the first moment of this shaded area, red, would be 2 times 24 times 84 for the rectangle. Then moment arm is half of 84, 42, plus area of triangle 1/2, 28 times 84, then 1/3 of 84 is 28 also. So Q1X is 2 times quantity 24 times 84 times 42 plus 1/2 of 28 times 84 times 28, where 28 here is the distance of the centroid of this triangle from the centroidal x-axis, which is 1/3 of 84. So Q1X is equal to 235,200 mm cube. Then for this area, Q2X, distance, because the centroids are below the centroidal x-axis, so it's negative. So Q2X is 2 times quantity 52 times 60 times negative 30 for this rectangle. Then for the triangle, 1/2 of 20 times 60, then 2/3 of 60 is 40, but it is negative because the centroid is here and the distance to the neutral axis or centroidal x-axis is 40, but it is below, so negative. So Q2X is negative 235,200 mm cube. So to explain the result, they are equal because this is the centroidal x-axis. Remember, from Varignon's theorem, the moment of the resultant about C is 0 and it is equal to the sum of the moments of its components. So area will have, if positive moment about the centroidal x-axis, while area 2 has negative moment about the neutral axis, so it is 0. So for the explanation, the sum of the first moment of areas about an axis through the centroid of the entire area is 0, which follows from Varignon's theorem. For level 30 problem, determine the coordinates of the center of mass of the bracket, which is made from a plate of uniform thickness. So take note that this is the origin, X, Y, and Z. So let's tabulate the result for the solution. Call this element 1, element 2, this rectangular plate, element 3, this semicircular plate, and element 4 to be removed, this circular area. So for area 1, we have element area in mm square, x sub c in mm, y sub c in mm, g sub c in mm. Then area x sub c, product, area y sub c in mm cube, and area g sub c in mm cube. So for element 1, the area is 1/2 of, the radius is 80, so this dimension is 160. 160, 1/2 of 160 times 100 is, that's the location of the centroid, 8,000. So the centroid is located to the left of the YZ plane. So its X is negative. So supposedly this distance is 1/3 of 160. And since this is 80, so negative 80 plus 1/3 of 60 is negative 80 over 3. So this distance is negative 80 over 3. Y sub c is, it lies on the floor. So y sub c is, for this centroid, below the xz plane. So y sub c is negative 80. Then g sub c is this distance here. It's positive 100 over 3 because that's a triangle. Then the product area times x sub c is negative 213,333, and area times y sub c, negative 8,000 times negative 80, negative 640,000. Then area g sub c is 266,667. Element 2, this area, 160 times 80. That's the location of the centroid. So 12,800. X sub c is 0, it lies on the y-axis. Y sub c is it's 40 mm below the x-axis, so y sub c is negative 40, half of 80. G sub c, it lies on the YZ plane, so 0. Then area x sub c is 0. Area times negative 40, negative 512,000. And area times z sub z, 0. For element 3, pi 80 squared over 2. So pi times 80 squared over 2, that's the location of the centroid, 3200 pi. X sub c, it lies on the y-axis, so 0. Y sub c, that distance is 4r over 3 pi. 4 times 80 divided by 3 pi, let's just put the value, 33.953 mm. Then G sub c, because it lies on the YZ plane, the centroid XY plane rather, so G sub c is 0. Then area x, 0. Area times 33.953, 341,333. Area times 0, 0. Then element 4, to be subtracted. Area is negative pi 40 square, so negative 1600 pi, that's the centroid. So the centroid is the origin, so x0, y0, g sub c0. So the product of area and xc, yc, zc would be 0 respectively. So summation of areas, we add all these column values. So sum of areas is 8,000 plus 12,800 plus 3,200 pi minus 1,600 pi. That's 25,826.55. Then summation of area x sub c, there's no other value except negative 213,333. So negative 213,333. So xg is negative 213,333 divided by 25,826.55. So xg is equal to negative 8.260 mm. Then summation of area yc, so we add these columns here, negative 640,000, negative 512,000 plus 341,333. That's negative 810,667. So therefore YG is negative 810,667 over 25,826.55. And that is equal to negative 31.39 mm. So finally, for sum of AZ, so there's no other value, 266,667, then mm cube, then G sub G is 266,667 over 25,826.55. So G sub Z sub G is equal to 10.33 mm. So that's it for this problem.